What's up, guys? Welcome back to the channel. Mitchell and I are here with you again today, and we have a very special opportunity we want to share with you. Here today we have Alex and Owen, right, from MotoSolutions, and they have been kind enough to come up and visit us today and bring one of their newer pieces of equipment to do a bit of a demo for us and show us how that's going to work.
Awesome. Well, thanks for having us up.
Yeah, thank you for coming.
Cool. Looking forward to doing some rotors on this this beautiful car here. We got a BMW?
That's a 525i. Yeah.
525i with some pretty rusty rotors.
Mm-hmm.
So yeah, today we're going to be walking the boys through how to machine rotors with a ProCut PFM X9 on the vehicle rotor matching system, which actually not just machines the rotors, but matches the rotors to the hub with less than 1/1000th of an inch of lateral runout. So car dealerships are using these not just as a retail tool, but to address issues with vehicles that have brake pulsation. You guys have experienced brake pulsation before.
Yep.
It's a pretty common thing. It's also a very common thing for consumers, daily drivers, and even mechanics in the shops that we go to call that warpage, warped rotors. It's such a common term, but what's actually happening is rotors are going on a hub with more lateral runout than the OEM says is acceptable. And across the board, that specification is 0.02 of an inch or less, right? So for everyone online here, just for reference, a hair's width is 0.03 of an inch, right? So when you're taking a brand new rotor and a brand new hub and putting two parts together, the likelihood of you hitting a specification under 0.02 of an inch or less is likely impossible.
Pretty tough.
Yeah.
And then that ends up being cause for people to think they need to just replace
the
rotors. Meanwhile, it's just the manufacturing wasn't quite.
Yeah, exactly. You're just taking two parts and mating them together and expecting to hit, a very low number, which isn't happening. You're not going to get pulsation right off the bat, but what's happening over time is that lateral runout with your foot relaxed off the pedal your rotor comes in contact with the pad every revolution, creating a thickness variation, high and low spots in your rotor.
Mm-hmm.
That's what makes your foot go up and down on the pedal. Right. People still call it warpage. You can call it whatever you want, but that's what's happening.
Yeah.
And most OEMs have adapted this ProCut lathe as a warranty tool to attack those issues in the service department when cars are coming back under pulsation.
So obviously brakes being kind of the main focus, but what other kinds of things does MotoSolutions offer? Yeah.
So we've been a master distributor for ProCut for 10 years, 11 years now. For the longest time, we were a standalone company. All we did was brake lathes. We're still Canada's #1 brake lathe company. So if you have an old, Amco, FMC, John Bean, one of those old school benchtop lathes, we sell parts for those. We sell consumables, cutting tips, silencers, spare parts for those things. But we ventured out into different lines such as compact hydraulics out of Denmark. So anything from shop presses to jacks to stands, wheel dollies, all sorts of things like that. We sell Martin's tire equipment, so everything from inflators. Again, they have their own line of jacks and things like that as well. We ventured into the heavy duty market and offering brake lathes for heavy duty trucks, trailers, buses. We have our own line that we've come up with called Brake Beaver. And we also have a line of heavy duty alignment equipment called Josem out of Sweden. So heavy duty alignment for truck and trailer, anything above like an F550 size truck.
Right. Very good. Well, if you want to kind of take it away, show us unpacking,
absolutely.
Quote unquote, and get set up.
For sure. So I'll wheel this over here just so we can see it a little bit better in the camera. Yeah. Can you see that all right in there?
Good.
Awesome.
Good.
So this is the ProCut PFM X9. ProCut's been around since the 1980s making on-vehicle brake lathes. They basically invented the on-vehicle brake lathe as we know it today. There were some caliper mount and other options before, but what we know today, ProCut is the pioneers of this style of machine. Again, it's a common misconception that rotors are too thin to machine. We hear all the arguments. There's actually data showing that rotors today are thicker with more material to play with than ever before. Wow. Yeah, and we haven't yet, but we're going to be sharing that and creating a page on our website about that, just because it is such a common misconception. But that information is out there. So what you see today is not just a brake lathe, but it is a rotor matching system. And basically how it works is that there's hub adapters that are all bolt pattern based. First thing we're going to do is we're going to mount that on the hub. You know, these go true to the hub. They're not vehicle specific. They're bolt pattern based. This machine will do anything from a small 4-bolt right up to an F550 size truck. And then there's bigger machines for, you know, the heavy duty trucks and stuff like that. So you were mounting those adapters, depending on the bolt pattern. And then we're going to be machining the rotor. ProCut has the 3 C's of cutting a rotor. The first is connecting the machine. The second is calibrating the machine for run out, because this is going to take a measurement of how much run out is on that hub and that stack. And then the third is cutting the rotor. This is considered a 1-cut lathe, but with rotors like this, we're probably going to have to do a second, maybe even a third cut. So we'll be sure to get some video of the rotor before machining it, just so you guys see what we're working with here. But yeah, this is a pretty standard setup here. We have over 500 of these on the street just throughout Ontario alone, and thousands throughout Canada. This is your computer here where you kind of control everything. It comes with a lug nut kit, a tool kit, comes with a full package of cutting tips and silencers, everything you need. This is your cutting head here. Minimum cut on this cutting head per side per pass is 0.04 of an inch. Maximum is 15 thousandths of an inch per side per pass. Typically, we're going to be anywhere like 6, 7 thou per side. You know, maybe 8, you know, just kind of depending. With stuff like this, rust being iron oxide is actually harder than our tungsten carbide cutting tips that we're cutting with. So when we're cutting rust, we're actually going to be trying to get past the rust into metal and cutting the metal, versus trying to take multiple light cuts on rust where we're going to damage our cutting tips and have to do a quick rotation. How the machine works is that there's a flange set up here, and this flange spins against the hub adapter that we have mounted on the stack. And there's a magnet passing through a Hall effect sensor telling the computer that you have rotation and location. It's then striking the solenoid out, turning the gears inside that flange, and it's adjusting that plate until it reads a number under 1/1000th of an inch, gives you 2 green lights, good to cut the rotor. And that's basically how it works in a nutshell. The latest version of what you see here is still AC driven. It's belt driven versus the old machines being gear stacked with oil. Everything has tighter rear ends on it nowadays, and just tighter drive axles. So they moved to a belt system, just a little bit more torque and stuff in there. Okay. So first thing we're going to do, guys, we're going to mount to the front here. Take a look at those rotors. The hub face here is pretty dirty. So I'm going to get Greg to clean that up. You can use a roll lock. You can use a wire wheel, really anything that cleans that up.
Yeah. You don't want anything changing the trueness of that surface.
Exactly. Exactly. This machine is going to take a measurement of that hub. So if we put that adapter on and you didn't clean it, and we can feel any rust on there, it's sitting with a few thousandths of an inch of intolerance. So we want to make sure to do what I call our housekeeping. Now, if these were fall off rotors, take the wheel off and those fall off right away, we're going to clean both sides of the rotor, the hub face, put the rotor back on, and then machine it. But because these are either fixed on, bolted on, or they're seized on, I'm not going to take a sledgehammer out to whack those off, right? Then we're messing around with the hub and how everything, right? So if they're seized on or bolted on, leave them on in place, put your adapter on, and cut the rotor. That thing's not going anywhere, okay? So you're good to go. Yep.
I am waiting.
You let me know what you think. It's got a little bit on there, but it's 100 times better than it
I'm happy with that.
was.
Yep, that was great. Awesome. So guys, the first thing we're going to do is we're going to figure out what adapter to choose. And the best way to do it is likely experience. You pop an adapter on there. If it fits, awesome. Another thing you can do is either visit ProCut's website, or they have a phone app called ProCut Adapter, where I've already gone ahead and I've put in the vehicle make and model, and it's showing me on here which adapter to use. If you expand it, it's even going to show you what pattern number to use. So I can grab my adapter. There's numbers on the adapter. It says 50-693, and it says revision number 4, and it shows me pattern number 4, which is right here. Okay. So I can pop that adapter on knowing that it's going to fit. It's very handy if you work in a shop that services lots of different makes of vehicles and you're not sure whether you have the right adapter before calling the job. You can just double check. Yeah. Most vehicles, we're either going to be using the wheel studs that are on the vehicle and corresponding nuts, or the OEM nuts if they fit. In this case, because it is a BMW and they have their own special thread, we're going to use the wheel bolts paired with the adapter. Okay, so I'm going to go ahead and pop these on. These adapters are cast iron. They call for 40 foot-pounds of pressure, so you don't need to torque them on. I basically go hand tight on them. On 5 studs, use 5 nuts or 5 bolts. Again, this machine is calibrating down to the thousandths of an inch. So any movement in this adapter, inconsistencies might cause this lathe not to calibrate for run out. One important note too, guys, always start on the side of the vehicle where your caliper window is on the right. In this case, it doesn't matter. You could really machine anywhere because there's no backing plate, but typically you have a backing plate and your caliper window, and you're accessing the rotor where your caliper window is.
Mm-hmm. Yeah,
now,
I actually pulled all that out.
Did you? Yeah.
It was scrubbing anyway.
Yeah.
So forget it.
So in those cases where you have a backing plate that you're not going to be taking off, keep an eye where your caliper window is, and you're going to be using the lathe upright first, and on the other side, the lathe is going to be upside down. Typically, you're doing axles at a time, and you'd start upright and then go upside down, right? In this case, we're doing something a little bit different, but that's okay. I'm just going to grab my wrench.
Yeah, I guess having known that, we should have set up to do 2 fronts.
That's okay. Yeah, no problem. So again, hand tight only, guys. We're not going crazy on these things. These adapters are designed and intended to last the life of the machine. We have 20, 30-year-old adapters out there still going strong. So
Have you seen many instances where users did over torque them?
oh yeah, yep.
And what is just kind of
They're using guns on them, and they crack. The cast iron likes to crack, either from being dropped at a high height or just over torqued. You know, flat rate mechanics in a busy shop,
they're just trying to do it as fast as possible.
they're trying to do it as fast as possible, right? Okay, so we're cutting pretty low here today, guys. A lot of the times, you know, we're going to be right at the top of the trolley or somewhere in between here. This machine's just on a shock at the back here, so you have height adjustment on here as well. We did also bring the boys what we call a low boy shock, where if you're, you know, machining or doing a brake job on a driveway somewhere, you could get much lower than where we're at today. I mean, what are we at, like 2 feet there? Yeah. I'd say about that. So what we're going to do is we're going to wheel this right in. And I'm just watching everything here.
Yeah, we got tight quarters here.
That's okay. We're working with it. So my goal is to get the silver guide pin on the adapter into one of the 12 holes on this flange, and just thread this drawbar in to attach the machine to the adapter. So I'm wheeling this in. And if for whatever reason I was having fitment issues right now, let's say my machine was hitting the bumper, I didn't like what was happening over here, I could take this spacer off the trolley, attach it to my adapter, moving the machine further out. There's always a way to machine the rotor. I could turn that wheel a little bit to get in there. There's always a way to make it happen, right?
And then does the cutting head have extension as well?
Yes, it does. Yeah, for larger diameter rotors. You know, if we were installing this in a BMW dealership, we would actually be looking at different cutting heads. For larger diameter rotors, like a 750 Li, where the rotors are massive on those things, you can definitely do them. This is our standard cutting head, but it does have a second holes on the back. So you can pop those arms out to do larger diameter rotors, no problem. So first thing we did, guys, is connect the machine. If I didn't like where my machine was sitting, I can move this around, or I could even bring this into the wheel well if I wanted to, right? So I'm just using the clutch handle to feed the cutting head in there a little bit. The first thing I want to do before messing around with the cutting head or anything once I'm connected is start the machine up and calibrate it for lateral run out. Now, if you take a look at the machine, it's moving like crazy. This machine was recently serviced in our shop. It's a demo lathe. we took the whole flange apart, which is a bunch of high-sided and low-sided plates. So they're all just stacked on top of each other right now.
Right.
When I press and hold start here, it's going to take a measurement. It's showing about 22 thousandths of an inch of run out on that rotor. Now, it's not 100% accurate because we were messing around with it and cleaning it in our shop. But the number it's going to spit out at the end here, once it's done calibrating, is going to be accurate to how much run out we have on that rotor when we're done. Right. And that number is actually an accepted number from Chrysler, Honda, Acura, Nissan, Ford, GM. They say that if you have a car that comes back under warranty under pulsation, you can hook a ProCut up to that car and measure the run out with the machine. So they'll say, what's the first number that pops up and what's the number after machining? And that's their warranty fix. Okay. So we're going to have 0.6. Now that's not 6 thousandths of an inch. That's 6/10 of 1 thousandth of an inch. Once you get 2 green lights on here, we're basically ready to set up our cutting head and take our cut. So I can turn the machine off at this point. Okay. We're going to come down here. Our cutting head has two levers on it. This is also a safety shutoff. So I'm going to bring this along here. And as it feeds out to that point, it engages that switch and shuts the whole motor off. Okay. That way, you know, it's kind of a set it and forget it thing. You can set this machine up. You can be working on the back. You could be working on another car in the shop, and it's going to safely shut itself off before feeding into a wheel well or damaging anything, which we've seen. So back lever, they're all on springs. So if you don't like where they're sitting, you can just move them around. I'm going to center my cutting head. Okay. So I'm just eyeballing it and I'm tightening that back lever. Okay. So I'm going to bring my cutting head in. And I want to come in and I want to touch the rotor. But you can see our cutting tips are quite far away from the rotor itself. So what I like to do is what I call the flat rate method. So I'm going to pinch both tips. You can hear they're both touching the rotor. And I'm going to move both dials in until they stop. You don't want to overdo it because you can break the coating off the tip. So as soon as they stop wheeling them in. Okay. Now my tips are touching the rotor. I don't want to start the lathe up right away. So I'm just going to go 1, 2, 1, 2. Just manually make sure your arms aren't touching, and I'm going to start the machine back up. Now my tips are very close to the rotor. I'm going to just lift up our chip tray so we don't have a mess. And on the inside dial first, I'm going to come in until I hear full contact. I don't want to have to stick my head in the wheel well. That's why I do the inside one first. Okay. Just coming in nice and slow. We got contact. Outside one we're going to see. Now you can see that there. It's showing obviously thickness variation, probably from the rust.
As light as you need more light, or you can
So first thing I'm going to do is I'm going to feed this out. I like to just manually clean up any rust near the edge. I haven't tightened up my arm knob or anything yet. Okay, I'm leaving that loose, and I'm going to feed my cutting head all the way in here. Our goal with the scratch cut is not to take any material off. It's to identify where the low spots are in the rotor. So if I get halfway in here and I'm still missing like that, what I'm going to do is I'm going to come in until I have more of a solid line. Okay. Now I might actually have to make a pretty large adjustment here. So yeah, if you guys take a look at this here, you can see our feed screws coming in. It's going to contact the rotor.
Yeah.
Okay. Now, again, if I was at a BMW shop and I realized that, I would make a mental note that any 5 Series BMW, I have to put a spacer on.
Right.
Okay. But because I don't do these all the time, I'm doing hundreds of different models of cars. I just don't know what car needs that spacer and what ones don't. The reason we don't leave it on is because it can cause other fitment issues on other cars. Okay, so what we're going to do is I'm going to redo what I just did. Okay, it's okay for the video because, you know, that's just machining, right?
It might just happen to us.
And it just might happen to someone who's watching this video. So there's always a way around it, and just knowing what to do in these scenarios. So I'm going to back that all the way out, and I'm going to take the machine back off. Super quick fix here. I'm going to grab this spacer real quick. bring that out, and I'm just gonna feed that right into the, I'll show you what I'm doing on camera here so you guys can see it too. Sorry guys.
It's all good. Yeah.
That'll screw right into the nose of the adapter, making the adapter longer. Okay. And then we're gonna remount the machine and recalibrate it.
Bust at the end of the night, under street lamp, red face flame by the light. I'm going away, I'm going away, I'm going away. And the sun gonna shine on a brand new day.
All right. So we're in as far as we need to go. Your whole point is clearing where your pad contacts. Sometimes you're going to be able to get in much further like this where there's a big gap in between the hat of the rotor and the friction face. We're going to go ahead and take our cut now. Again, these rotors are pretty bad, so we're going to take more of a deeper cut. Each line on this cutting head is 2,000 or 2.5 thousandths of an inch. So you can see here, we're not at zero. So if you wanted to zero it out, you pop it out and you bring that dial back to zero, right? So 2.5, 5, 7.5. We're gonna take 10, okay? This one, same thing. We're gonna tighten our front black lever up, which locks the arms into place. And we're gonna grab what we call a chip deflector. Pushes all the chips down into the tray, but it also acts as a vibration dampener when machining, okay? Those grooves sit on the tips. That spring sits underneath this handle here. So you can turn it off to set this up, or you can just simply open it up, pop it on, and then engage your feed, okay? When machining metal, there's a harmonic buildup. If you let that harmonic buildup get too high, then you start getting chatter. So the whole idea is just to keep that chatter low, okay? Now, typical cut time on this unit is about 2 to 3 minutes. 5 minutes to set it up, 2 to 3 minute cut time. And 9 times out of 10, you're going to get one casting done.
What's your guess on this one? 1, 2?
I'm going to say 2. Yeah, I'm going to say 2. Yeah, just based on what we started with.
Yeah.
And it's going to come down to surface finish. It's going to cut the rotor, no problem.
Yeah.
And you could slap pads on there and drive down the road and it'll be good. Mainly because you have no run out. But if you want to go for a better surface, then we might even have to rotate the tips and take a second cut. The tips are 3-sided, conventional triangle, as you can see there. Yeah. They're not 6-sided, so you cannot flip them upside down and use them a 4th, 5th, and 6th time. They're 3-sided only. Yeah. So one thing I always get guys to check too is just feel what we're taking there. You can feel it with your bare hand, like what we're taking there. That's a 10 thou cut. I'd say it's on the heavier side, but we're not taking a ton of material off that thing, right? It's nothing crazy. So,
what did you say the minimum is
4 up to 15 per side. So we're on the higher side here.
Still cutting this one?
Yep. Sometimes, guys, too, you'll see this machine moving radially while it's cutting, and it's all based on how that adapter grabbed onto the hub. Radial movement is perfectly acceptable because if you had no radial movement whatsoever, you're getting one cut, like a record, all the way around that rotor, which you don't want.
Not a surface.
Yeah. Back when guys used to machine on a bench lathe, they still do. We still sell bench lathes,
Yeah.
but you're supposed to break up that directional finish. You're supposed to use a special tool to break up that surface finish. This machine gives you that finish right off the bat. So it's not like one cut all the way around. It's actually cutting that non-concentric ring in it.
Must be somewhere welcome me into the fold. Blooming flowers, as much as I can hold. I'm gone away.
All right, so we're done there, guys. I can kind of see the surface finish, we're going to have to take a second cut, but that's okay. Why don't you feel that real quick, what we're dealing with there?
Yeah, it's tenfold better than
Yeah,
what we started with.
it's pretty good compared to what we started with.
Yeah.
So what I'd actually do in this case, just to get a beautiful finish for YouTube, we're going to rotate the cutting tips. I could cut it again with those ones, but on average, you're going to get about 10 to 15 rotors cut with a corner of a tip.
Right.
Demo unit, I didn't even rotate the tips before coming here once I saw those things, because I knew we were going to be chewing through some stuff.
Whoa.
So anytime, guys, that I rotate the tips, I'm just brushing off the insert screws. That way I'm not stripping anything out.
I'm gone away. I'm gone away. And the sun gonna shine on a brand new day.
I also just clean out the
Bring it over here for a
little
second.
spot that it sits in.
A brand new day for love. Brand new day for me. Brand new day for love. Yeah, I'm motorboating.
Okay, guys, so I've rotated the cutting tips very quickly. We're going to go ahead and just take another cut. Quick rotate. I feed it right back in. I'm not recalibrating anything. I'm going to slowly feed it in, and I'm going to come in for that scratch cut again, just so I know where my cutting tips are at. There's the inside. There's the outside. Feed it all the way in. Okay, we're past our spot. We're going to go 1, 2, 1, 2. Again, that's pretty minimal cut there. 4 to 5 thousandths of an inch. Yeah, just a surface finish cut. We're going to engage our feed, and we're going to pop our silencer back on. Okay. And another 2 to 3 minutes. Another product that a lot of our used car centers or even retail shops are using is Rotor Coater. It's a zinc-based aerosol paint, essentially. And guys are treating rotors. So no different than you get a treated rotor at a box.
I was going to say the silver coating comes on.
Yeah. Same concept. And our used car centers love this because they're putting vehicles back on the lot after machining, or even after putting rotors on a vehicle that didn't have coated rotors on. Right. Just doing a quick brake job, spray this on. The great thing too is it's going to help prevent rust on other components of the braking system as well, like the hub and the studs and all that.
Yep.
So we use it on all our vehicles, but we also sell a ton of it as well. Very cool product. So
what does this one run usually?
So our kits with this machine run anywhere 16, 17,000 Canadian. A lot of the times, you know, we have demo units or used units and stuff like that as well. So now if we did let it run out and we weren't here right now, obviously that's going to ride on the rotor. It's not breaking anything, but we did set up the safety shut off. So it's going to continue to feed out and it's going to shut itself off once it reaches that point there. Okay. Obviously, if you're standing by the machine, keep moving along, shut the machine off, and feel your cut. It's beautiful. Check that thing out. You can almost see your reflection in it.
Yeah. Fool somebody, we put brand new rotors on.
Yep. Now, most importantly, like surface finish aside, that rotor has no run out on it. Mm-hmm. That's the most important thing here. This is called rotor matching versus just machining a rotor.
I was going to say, because maybe the ProCut ones or the Brake Beaver ones do, but I think most benchtop machines don't have that.
No.
They're just machining both sides.
Exactly. Yep. Yeah, any benchtop machine doesn't have any tools for run out. And it's not even a thought. where, the most important thing about this machine is that it's matching the rotors to the hub where they're sitting.
Mm-hmm.
So if this was a fall off rotor and we just machined it, and if it was a driven axle, I went to the other side and that driven axle spinning this side, and we didn't lock that rotor back into place and it falls on the ground, we have a 1 in 5 chance of putting it back where that rotor was sitting and matched to.
Right.
So we either have to index the stud and index the rotor and set it off to the side, or just jam a nut back on it so we know where it's sitting. No different from a brand new tire and a brand new rim assembly. Why do you have to balance them if they're both zeroed at factory?
Because if you don't put it on exactly where it was intended to be, and a lot of people don't know that's what the little paint dot is for a lot of times. But yeah, if you don't match it up.
Brakes are the same thing, and you're taking, parts that are made in different parts of the world with different specifications on different machines from different people. They were sitting on a shelf for months on a boat. They were sitting there, you know what I mean? It could be years old. Who knows? So this is a very important process that a lot of people kind of overlook. So
that's maybe one vote for going for an on car lathe instead of I always thought, hey, I'll just get a bench top, but knowing now about the
for sure the run out, bench tops can be great, and there's a place for it too. You just you're doing more what I call housekeeping. You're making sure you have no run out on your stack before and after, right?
Which we do. Anyways, we always make sure the hub's spotless and a little bit
for
of
sure
ATCs or whatever.
Get a proper dial indicator with a roller anvil on it. Make sure that your rotors are in spec and you're good to go. Yeah. So guys, we're done this rotor. We can move to the next. Typically, we'd be moving to the other side of the vehicle where the lathe is going to be upside down. Mm-hmm. So I would actually prep for that here because the hub spacing is the same on either side of the vehicle.
Right.
So my cutting head is already centered for over there. Mm-hmm. So I'm literally going to flip it upside down, hook it up, calibrate, and feed my cutting head in. Yeah. Right. And the only thing I have to do is loosen off my arm knob and open up my cutting tips. So now my cutting tips fit over top of that rotor.
Brand new day for me.
All right, so we're going to try and finish up the last of the machining on the 39 BMW wagon here. We decided to not even bother machining the other side front rotor. So the last step with the brake matching machine, rotor matching machine, is to do this other rear rotor, which looks to be fairly new. It just needs a good surface treatment. So we're gonna get the hub face cleaned up as we did before, mount the adapter with the spacer, and then bring the machine over. And I think we talked about it earlier on, but when you flip to the opposite side, you have to turn the head of the machine over depending on where the caliper window is, because the rest of this whole circumference is splash shield, so you can't machine the back. When we did the left front, it was right side around, so this one will be upside down, which just makes it a little more challenging to operate, but still no problem to get it set up and have it go. So without further ado, I'm gonna clean up the hub face here. We'll throw the adapter on, bring the machine over, and cut this rotor.
Brand new day for love. Brand new day for me. Brand new day for love. Brand new day for me. Brand new day for love. Yeah.
Adapter here, and like we talked about earlier in the video, if you're unsure which adapter to use or whether you have the right one, definitely get the ProCut app. You can hit the machine you're using and then type in your vehicle you're working on, and it'll tell you which ones will fit, and then that'll tell you whether you have the right one that you need. So for this car, we are 5x120. 114 and 120 are in the same hole for this one, and this adapter, I think the number might be on the front, so I can't even read it. but I think we also mentioned that earlier in the video as well. But each adapter should have the model number on it so that you know when the app tells you use such and such number, then you can identify it. Okay, so we are hooked up, and the cutting head should be all good. I had to adjust the arms to the second hole out when I was doing another car the other day, so hopefully that will work for what we have here. It's going to be very close. I don't know how far I can go before it falls out here. And then let's see if I can make sure I do this correctly when you're looking at it upside down. So I'm going to back off our two adjusters. Mosquitoes are coming out. And then I'm going to look and try and just center the carriage in the middle of the rotor, which that's looking pretty good. Okay, and then before we do anything else, we're going to make sure everything's clear. I'm going to fire up the machine here, which again, everything's upside down. The switch is somewhere over here. There we go. Okay, and then we push the start button. And it should do its calibration. This is where the hub face being clean is critical, so that when it's finished adjusting here, it's ready to go. So we got 0.7, less than 1,000th of an inch, and we've got the green ready to cut light and the green optimum light. So we are set to actually start cutting now. So we're actually going to flip the machine off so we can set the position of our cutters. So I'm going to bring the cutting head into about a quarter of the length of the braking surface, and then I'm going to squeeze the arms in against the rotor and bring the dials in until they just snug up. And I'm going to back each one off a couple of little turns so that we're not making contact. And then we'll fire it up again. And then now we're going to bring each one in slowly until it's making full contact with the rotor, starting with the inside one first. And you're mostly just listening for that one. There we go. And the other one, you can see it on this one. Right there. And then we're going to come out. Out. And then we're going to go all the way in. Do here, I'm noticing we're a little tight on the bottom, so I can tip this up without messing up any of our adjustments, which is great. And that way we can also put the cleaner block cleaning and vibrations on the leading side of the cutting. So fire it back up again. And continue going in. And if we lose contact, then you can always bring in a little more. Uh-oh. Did we blow a breaker? still have lights. Oh, the button just popped out, so I didn't push it far enough, I guess. Oh, no. Okay. Interesting. We have... Oh, okay. So, the little, what you call it, safety switch with the adjustable stop is tripped. So there you go, it works. So we'll see if that's enough travel to let us go in. It's supposed to be on the outside of it so that when you... Yeah, that's not going to work. But anyways, we'll just adjust that for now and we can readjust it later. Let's try that again. It should work now. Yeah. Grinding up the flat wheel a little bit. Okay, so then we're going to do 2 lines on each dial first. I really can't see, it's really dark. Go 2 lines inward on each, or so. 1, 2, and then we're going to engage the automatic feed, hopefully, and let it do its first cut. So that should be taking, I believe, 5/1000ths of an inch off of each side of the rotor. How good the surface finish is on that. Not super great by the look of things. Yeah. I don't know if I'll be able to pick it up on the camera, but it's, you can see it in the light there, it's pretty coarse looking, feeling. Maybe we'll try one more cut, just 2.5 thou and see. The back feels pretty decent, so maybe we're okay. Let's try one more small cut, a nice finish cut, and then if that's decent, we'll call that good. And we'll flat sand the pads so that they'll seat nicely on the machined rotor, and that's just about it for brakes on this car. Yeah, something a little bit odd is maybe happening with the cutting tips. Most of it is quite good. Just the last little bit for some reason is The inside's good all the way out, so maybe it's just the outer cutting tip has a bit of a burr on it or something. Where am I going here? Yeah, you can kind of see there's what looks like a step. And it kind of is a step, and it's kind of not. But the rest of it looks good, so... I don't know whether it's worth... Maybe we try one more cut just on the outside, because we can do that as well if we're not liking how it's looking on one side. The other side's good. The back to me is perfect, so we'll leave it alone. We'll try maybe just one more 2.5 cut on the outside, and we'll call it good. That looks much better this time. Just give it a little buff. That looks pretty good. It is still a bit coarse, which I think definitely means we should rotate that cutting tip, but the back is much more fine, but we're going to call that good. So then with that, you can wind your head back out of the way, hold down on the, I think I got too much, hold down on the raised lower head and unthread the bolt. And then carefully pull it away from the car. And then you can set this down. And there we have it. So that rotor is done and ready to go. We're just going to do a, like I said, a flat sand on the pads so that they will mate to that new rotor surface nicely. Finish replacing the rest of the front parts. And that's the brakes done on this car. So. Okay, so yeah, we finished up the machining of that right rear rotor last night. So the last step for the back, for now at least, is just to give the pads a bit of a flat sand job so that they'll hopefully mate a nice new surface to the machined rotor that we've just done. This is the outer pad. It's pretty decent. You can see there's an area there that wasn't making contact, but it's fairly flat, so it should be pretty easy to sand up. This one, on the other hand, the inner one, which is the same problem I had on the other side, there's a good step, a good amount of material missing just in that first 3/8 of an inch for whatever reason, however the rotor was wearing. So it's going to take a lot more sanding to bring that down closer to flat, which is what I experienced with the left side as well. But all you do is get a pane of glass and try and put it on a flat surface. Get some sandpaper. I've just got some used 80 grit, and you just try and keep the pad nice and flat on the glass, and you sand back and forth. Pay attention to if the sandpaper is getting clogged up. Most of it will just fall off or blow off, and we're just looking for it to be that shiny gray across the whole surface, so there's a little bit left in that one spot. So that's all I did on the other side. That's all I'm going to do on this one, is just go at this for a bit until we're happy with it. The other option, which we have done before as well, is belt sander. like a bench top belt sander. The reason I don't want to do that on these ones though is because we don't have a ton of lining left in the first place, so I don't want to accidentally take off too much, because it obviously removes material much faster than this piece of sandpaper here. So getting close, a little bit left. That would probably be okay as it is. I'll try a little bit more here. But since we've machined the rotor, we want to have the best contact surface we can get. It's pretty decent. Just a little tiny bit left there, but I think we'll leave that, and as the pad wears, it'll bring that up to flush and everything should be good. So yeah, that's all there is to that. I'm gonna spend a bit of time on the other one here, which is gonna need a lot more sanding because of that step. And I think Mitchell's gonna probably get started on putting the new pads and rotors on the other side of the front, and just kind of give you guys a time lapse of what that looks like. And then that'll pretty much wrap up brakes on this car finally, I think, for now anyways.
Okay, so that's the finished product.
All right, so there we have it. We've done both rotors on the left side of the car. This rear one looks fantastic. I think we'll be able to just go right ahead with it. Front one, we'll have to measure and see, but it looks fantastic. Huge thank you to Alex and Owen for coming out today and showing us everything about this. And I look forward to all kinds of future interactions that we'll have with other equipment and whatever we can get ourselves into.
Awesome, man. Well, thank you for having us in.
Thank you for coming up. I know it's a bit of a drive, but it's
all right.
It's a nice drive up this way.
Beautiful up here. Yeah, beautiful day. So
yeah.
Anybody ever need anything for their brake lathe, don't hesitate to hit us up, MotoSolutions.ca. Happy to help. So
You guys serve outside of Canada?
we ship right across the world. We've shipped brake lathe parts right around the world. So anywhere you are, just reach out to us if you're looking for something, and we're happy to help.
Right.
Yeah.
And you guys are in Sunderland, Ontario.
We are, yes. Sunderland, Ontario. So about an hour from the GTA. And our service truck actually works out of like Dixie 401 area. So we're actually right out of the city. So yeah.
Okay. Awesome. Well, thanks again. And we'll finish up this car at some point, and we've got a couple other ones. There's a, I don't know if you saw there coming in, there's a 90 Miata red one there that's going to be the next one. So
awesome, man.
Should be a fun project.
Very cool.
But yeah, anyways, don't forget to like, subscribe, comment. If you have any questions, hit up MotoSolutions on Instagram and hit up their website there and contact them for any brake or other equipment needs. And we'll catch you on the next one here.
Thank you, man.
Peace.